how's that? Well, the naming system goes like this. You have a prefix and the name of the first element, prefix and name of the second element. Now, if the first element, if there's just one, you don't have to say mono. You don't say monocarbon dioxide. You just say carbon dioxide. Okay, so if it's just one, you don't have to say mono for the first one. Okay, for the second one, you've got to say whatever it is. And what you use are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And so NO would be nitrogen monoxide. What would CO be? Carbon monoxide. Okay. NO2 is nitrogen dioxide. CO2 would be carbon dioxide. N2O, which is laughing gas, by the way. What is that? It is two nitrogens up front, so it's dinitrogen monoxide. Okay, H2O, what would that be? Water. Or dihydrogen monoxide. Yeah. PCl5 is phosphorus, and there's 5, so it's pentachloride. You do stick the IDE ending at the end because it sounds way cooler that way. That's why they did that. Honest. Okay, SF2, sulfur difluoride. P2O3, diphosphorus trioxide. And now I'm going to let you guys name these. Just for fun. I didn't want to have all the fun. So this one right here, what is that? PH3. PH3, what is that? Phosphorus? What? Phosphorus trihydride. Phosphorus trihydride. Okay, N2H4, what would that be? Dinitrogen tetrahydride. Or hydrazine, rocket fuel. That's what that is, rocket fuel. Just thought y'all know. Okay, last one. What about S2F10? S2F10, what would that be? Yep, disulfur decafluoride. Decafluoride. And that's how you do that. Oh dear Lord, have we finished naming stuff? Yeah, we maybe did. Okay, well, good enough. So now what do you want to do? Let's go on to more formula math stuff. Okay, this you guys have done. You actually did this on the test coming up. I mean, the test you took. The test you had before, you had the stuff that's coming up that we're going to look at, is what I meant to say. Okay, using molar mass to count molecules by weighing it. So you go from grams to moles to molecules. Now, 2 weeks ago, it seems like an awful long time ago, but 2 weeks ago, I asked you guys, I said, imagine you go in and you're weighing your sample and you feel a tear coming on, and so you weigh that tear and you want to know how many water molecules are in that tear. Do you remember that? You don't remember that? Yeah, that was a lot of years ago, wasn't it? Yeah, okay. Well, there was one like this on the test, okay, where you go from grams to moles, and then from moles to number of molecules, okay? So how do you do that? Well, you're given a weight, and you're asked to give number of molecules. In this case, it said how many CO2 molecules are in 10.8 grams of CO2. So now, with every problem, what do you start with? You start with what you're given. So we start with 10.8 grams. Now, we have to convert that to moles. So we need to know how many grams are in a mole. So how do we do that? Well, if it's a single atom, just look it up on the table. If it's a molecule, CO2, you've got carbon, you've got oxygen. This came off the periodic table. You've got one carbon, two oxygens, and then you add them together. Okay? So we've got grams here, moles here. So grams cancel. And so what have we got? We've got moles. And you guys know how many things are in a mole. So what you do, we cancel grams. And now we've got 6.022 times 10 to the 23rd molecules in a mole. So now we cancel moles. And so what are we left with? Molecules. And that's what you want your answer to be. You want your answer to be molecules. Okay, so you all had worked one like this before. In fact, you had one like this on the test. So I feel like you ought to know how to do that. Okay, go ahead, turn the page, please. Okay, what we're going to talk about now is mass percent. It's an element's percentage of a compound's total mass and how you get it. Okay, so the example that we're going to work is with Freon. Freon is CCl2F2, and so I've got it worked over there on the side. Okay, so we've got one carbon, we've got two chlorines and two fluorines. And these numbers I got off the periodic table. Well, in all honesty, I couldn't see the periodic table from here, so I asked people, and they told me. The only one that I took a little bit of issue with was the fluorine. I always round it to 19 even, but they said it was 18.99, so that was what made it a little bit different. So you add them all together, and you get 120.89. If you look here, I got 120.91 because I rounded my fluorine to 19. So how do you get mass percent? Well, if you want the percent of chlorine, if you want the mass percent of chlorine, you look over here. Here's chlorine. There are two of them, so it's 70.90. So 70.90 is from the chlorine. You put that on top, 120.89 is the total, and that gives you a percentage. Okay, so you guys see that. Now, let's take, we're going to do one of our own, just because we want to. Shit, don't say that. Don't be cussing. I got the,
Is Mr. Goggles around?
no, I got the video thing on. You don't want to be heard on that. Okay, M2H4. Is the hydrazine. Okay, there's the rocket fuel. Okay, what's the mass percent of hydrogen in hydrazine? What's the mass percent? Okay, so how are we going to do this? Well, there is nitrogen and there is hydrogen, right? So you look at the periodic table. Okay, what is the atomic mass of nitrogen?
14.1.
And hydrogen?
1.0.
Okay, and we've got two nitrogens and we've got four hydrogens. Up 4, not an H, this is a 4. And so this is 28.02 and this is 4.04. And altogether it is 32.06 grams per mole. Okay, So what we want to do is get the mass percent of hydrogen. So here's the hydrogen right there. So I'm going to put 4.04, and that would be grams per mole, over 32.06, and that would be grams per mole. So grams per mole will cancel, times 100%, and this is going to give us 12.6%.
Now the test, do you have to write out the units of it and showing it canceled?
It's a multiple choice test. Okay, so what can you use this for? What? Oh, what? Well, you can actually use it as a conversion factor. Okay? I'll give you an example. Are you ready? How many grams of hydrogen are there in 87.6 grams of N2H4? Okay, so how do we use it in a situation like this? Well, it's a percentage, right? So a percentage is per what? Per 100. So what we do is this. We say 87.6 grams of N2H4 times 12.6 grams of hydrogen per what? 100 grams of N2H4. And guess what cancels? Look at that. And so what does it come to? 11.0 grams of hydrogen. And that's how you do it. And there's another example in the notes using the Freon. We'll take a quick look at that in a minute. Oh, and we will take a short break at 1:45. Does that clock still work? Still broken. What kind of outfit is this?
Since the Twilight Zone.
Yeah, we'll have another Twilight Zone. Okay. Okay, mass percent as a conversion factor, which is what we did. Since percent means per 100, you do grams per 100 grams of whatever it is you have. And the example in the notes is what is the mass of chlorine in 245 grams of Freon, CCl2F2. So the same thing we did, cancel out the whole thing, and here's the grams of chlorine per 100, and that gives you grams of chlorine in that much. Okay, so it's right in there. Okay, so far so good, I hope. Is it so far so good? Okay. All right. We can also get conversion factors from chemical formulas. Okay. Freon, again, hate to use the same one over and over again, but I could Control-C, Control-V to paste it over and over, so it made it easier. Okay. If you've got 1 mole of CCl2F2, that means in that 1 mole of this compound, you've got 1 mole of carbon, 2 moles of chlorine, and 2 moles of fluorine. You can think of it like this. Say you have a dozen automobiles, and not counting the spare tire in the back, which isn't really a real tire. I mean, that thing's dangerous. It says don't drive more than 50. Okay. So if you've got a dozen vehicles, how many dozen tires do you have? How many? No, you got more than a dozen unless it's a unicycle.
You have a dozen vehicles.
How many dozen
Only
tires?
one tire?
No, you have 4 tires.
Four
I'm
tires.
not counting the spare tire.
Okay, you're not counting.
Not counting the spare tire. Then how many tires do you have? 4 dozen. Because there are 4 tires per vehicle. How many steering wheels do you have? And this is not a driver's ed car. If you've got a dozen cars, how many? Yeah, you got a dozen, or just you got 1 dozen steering wheels. Okay, you see what I'm getting at, right? Okay, all right. The same way with this. No different. No different. Okay, so 1 mole of this means that we've got a mole of carbon, 2 moles of chlorine, and 2 moles of fluorine, and 4 tires. Okay. All right. So how do you use this? How many moles of chlorine are in 35.8 moles of that? Well, you look here, it's 2 moles of chlorine per one of these. Okay. Now, this question right here is almost word for word question on the test last year. Okay? More than half the class missed this question. I don't know why. So I'm showing you the question because my goal is I want most everybody, if not everyone, to get this right. How many moles of hydrogen are there in 2.5 moles of hydrazine in 2H4? So how many moles of hydrogen? Well, we've got 2.5 moles of N2H4, and for each of these, there's 4 moles of hydrogen, and so that's what our answer is. I'm not kidding. That is the truth. That was the most missed question on the test. Yeah, seriously. And then there was one like the one before. Almost everybody, it was almost 100%, everybody got that right. Which leads me to believe that I don't know anything about people. What I think is easy, like I think this is easy, I don't think that's really hard, but it's harder than this. And when everybody gets that one right and this is that one, I start thinking, what do you think? You think, what the hell? Anyway, I'm going to turn this. Are you ready? I want you to be seasick. Okay, if we have grams of compound, we can find grams of elements using moles. Okay. What this is about is you've got mass of whatever compound you have, and you are looking for mass of the element. Okay? And let me walk you through this, just ever so slightly. It says, okay, how many grams of chlorine are in 25 grams of freon? So 25 grams of freon. What I do right here is get moles of freon. And then here, I say there are 2 moles of chlorine per mole of freon. Where do I get that? Right there, that 2, right there. I'll tell you what.
The first thing, are you getting the molar mass for the part 2?
For which one?
Versus 1 mole over 120, 91 grams.
2 moles per 1 mole of that. But the 35.4, is that what you were wondering
No,
about?
to the left. Yeah, there you go.
Well, we got that before.
Yeah, so I'm saying,
Yeah.
the second step, you get the total molar mass.
Yes,
Right.
in order to get moles. We'll work one of our own. That's what we'll do. We'll make one up. Are you ready? Do you have a calculator? You got your calculator. You can help with that. I know you will. Okay. How many grams of hydrogen are in... Okay, right side of the room, don't let me down. I need 2 random numbers. 7.
10.
No, just a 1 digit.
Just one digit.
Oh, she said oh. Okay, left side of the room, I need 1 random digit. 8. 2, 8, 4. Thank you, by the way. Appreciate it. Okay, so what are we going to do? We got to figure this out. Okay, so we have 70.8 grams of N2H4. Okay? And what I'm going to do is I want moles. And by the way, go work this on your own after we do this. Like, go away from here. Don't let this be the last time you look at this. Or I'm going to glance at it before I do the test. You need to be able to sit down and feel comfortable doing this. Okay, so how many grams are in a mole of this? Well, there's 2 nitrogens. That's 28 plus 4. 28 plus 4. Last time I checked, that was 32. Okay, so I got rid of grams. Now I got moles. Now what I want moles of hydrogen. So I'm going to ask you, how many moles of hydrogen are there in 1 mole of N2H4? How many moles? 4. And how do we know there are 4? Because there's this little 4 right there. That tells you there's 4. Okay, guess what happens here? Sound effect? Got rid of that, sucker. Okay, so now 1 mole of hydrogen is how many grams? You look on the periodic table, 1.01 grams. Okay, so are we ready? Are we ready? You guys got to do that thing you do with the calculators, because I don't have a calculator. I mean, it's not with me. I have one, but it's not with me. I'm calculatorless. I know you're going to help me out here. 70.8 times 4 times 1.01 divided by 32.06. That should give you the answer. 3 significant digits. What do you get? Thank you very much. And there we go. Now put a box around the answer. There you are. That's what you do. Now, it's not super hard. I swear, it's not super hard. But just so you get comfortable with it, try working this. Try working the one in the notes. There are more in the book. Yes, there are. There are more in the book to try. So try working these, and you'll be happy you did, because the next test, test 2, you'll do better on. You'll do much better. Yeah, you will do really better on this test 2, because test 2, not going to be any scientists or memorizing that stuff, other than, the little bit of stuff for naming stuff. Anyway, but there's going to be a lot of this stuff. Okay, so if you're comfortable doing this, you're in good shape. Now, it is 1:45. I want you guys to please run around, do whatever you want for 5 minutes, and then come back. Do come back. You're going to come back, right? Okay, and we're going to pause the video. All right, let me see.